Welcome to the Armada International podcast, and today's topic is how to ensure reliable communications to and from helicopters. And here to talk about it is Shaun Schaper, who's the Sales and Support Engineer with Cobham. So welcome to the podcast, Shaun.
Hi, thank you.
Good to have you in from dialing in from Cape Town. So let's get straight into it. Satcom, as we know, has been around for quite a long time, but it seems like it's been a struggle to bring this to rotorcraft, as we have talked about. I've heard a particular term called rotor shadowing. Now, can you explain exactly what that is?
Sure. So rotor shadowing is the biggest problem to overcome on getting Satcom working on helicopters. Just think of it as if you're shining a torch, and if you move your hand through the torch, you'll see every time your hand goes through the torch, you get that loss of light to whatever you're pointing it on. And that's exactly what starts happening to the signal going to the satellite, is you're getting however many times a second this hand going through, or should we call it a blade going through, chopping off the signal. And that really causes a lot of problems, especially when you're starting to deal with latest technologies of IP streams. You need to, the moment you start chopping data, you need to either retransmit it or you need to have forward error correction to fix it. So that has really been the challenge to get it working on helicopters, and we've spent many years mitigating rotor shadowing.
Because you're losing packets of information every time a blade interrupts the signal. You lose a packet of information, is that right?
Correct. It's not just the information, it's the synchronization with the network. It is the signal calculations. There's many things that get affected by it, including the data stream. And once you've lost it, unless you've got something in place to replace it, it kind of breaks most data streams. It breaks your connectivity to the network, etc., etc. So it really is something that is problematic, or used to be problematic.
Yeah. Well, what was the technology advancement that actually overcame that problem?
So the advancement was understanding what the shadowing was breaking.
Right.
And we noticed quite a few key things. So obviously the main factor that broke, say, something like a video stream or an ISR application was the packet loss and the jitter caused because of the rotor shadowing.
Yeah. We
could fix that by doing retransmissions, forward error correction. So we kind of also saw that certain things on the network were also breaking, like synchronization with the network. There was, how the network treats your quality of service when certain calculations go wrong. And taking all those 3 or 4 factors that we worked out, we created this SB-Helo X-Stream, which has higher forward error correction. It uses modulation schemes that are more resilient through the blades. We also play around with, I can't give the full details because it's proprietary, but we use, it's got to do with power levels and modulation schemes and coding rates and all sorts of stuff that we've spent years of testing to actually create a subset of rules on the network that are actually made specifically just for rotary wing.
Right.
And then we've got a set of rules that is just for fixed wing. So typically you just now log onto the network and you say, I'm either a rotary wing or I'm a fixed wing, and then from there you get treated completely different to how it used to be in the past.
And when you say we, was that Cobham alone, or was that Cobham working with Inmarsat?
It was a joint effort. In the beginning, it was Cobham working alone because Inmarsat from the beginning kind of said it's going to take too much time, too much effort to get it working in helicopters. We're not going to support helicopters, we're going to support fixed wing. So we were constantly finding ways to get Satcom working on helicopters. And, obviously through all those years of trying to get Satcom to work on helicopters, we gained quite a wealth of knowledge. And Cobham approached Inmarsat and we said to them, can we work together, run some tests and see if we can maybe get something together. And they were willing to do that. So we actually started doing that. And then it just from there, it kind of flowed. We started seeing worse results, better results, and we sort of got all the data together. And then it was in the last couple of years, it was a joint effort.
Right, yeah, from 2018 or so, you were working together on it.
Correct, yeah.
Just so that we get it absolutely clear, can you explain in simple terms what SB-Helo X-Stream is?
SB-Helo X-Stream is a new service offered by Inmarsat that mitigates the risk of rotor shadowing, essentially making it possible to have reliable Satcom connectivity through the rotor of a helicopter.
Right. If I was an operator of a helicopter, what difference is this really going to make to me in the day-to-day running of what I do?
So using the Helo X-Stream service, we've seen significant improvements of throughput, as much as 58% improvement, which is massive.
Right.
We've seen great improvement in packet loss, which is the real killer for IP streams, as much as 40%. And then all the other things that naturally come with that, like jitter, etc., that's all improved, giving a much better video stream without having to rely on all sorts of other methods and codics to fix what is lost.
How can you demonstrate that to somebody who is, interested in this but doesn't quite get it yet?
So people have been brainwashed that Satcom doesn't work on helicopters. And this is obviously from the years and years of people trying to get it to work, either getting partial connectivity or absolutely no connectivity. And everyone talks to everyone and they say, it just doesn't work, don't waste your time. We've tried this, we've tried that. So I think the biggest challenge for us is, Helo X-Stream fixes this and, try and brainwash the people that spreading the word that Satcom doesn't work on helicopters.
I think this has been a problem that's been recognised for quite a while, but it's been, I think the solution has been difficult to find. But obviously you've now got a good and working solution. And how did you approach the development of that, and sort of where did you start with Cobham? And can you just explain a bit about how Cobham approached the problem?
So, very good question. I've been involved with the Cobham helicopter projects since I think 2009 was our first attempt in getting Satcom working on a Mi-8 helicopter platform.
Oh, right.
We did many ground tests. We did a lot of stuff, and we worked out what the best ways were to try and mitigate the risk, but we could never get 100% working system. We always had, certain factors that were problematic, but it kind of was by finding optimal mounting location of the antenna and a whole lot of other things, size of helicopter, number of rotors, they all had a big effect whether we could have a successful install or a non-successful install.
What was probably the most difficult problem to overcome?
The biggest problem is obviously getting through the rotor mast, especially on larger size helicopters, because they have many more rotor blades.
Right.
And then the blades become wider, so they actually chop the signal of the Satcom. And this was what we needed to overcome through our development cycle. And we always were trying to get it working on the helicopters by focusing on more installation parameters. And eventually we started working with Inmarsat, and it was almost 2.5 years that we spent with just doing all sorts of testing, and we started optimizing. So we had already optimized the hardware side, but the main problem that we had to also try and do was optimize the network side. And that's where we focused a lot of our time over this 2.5 years, just running loads of tests through the rotors and optimizing the Inmarsat network side. And that was where Helo X-Stream got born, was a joint test campaign between us and Inmarsat. So we not only have the experience of getting Satcom working on the helicopters without Helo X-Stream, we take all of that we've learned, and then we've optimized the Inmarsat side, which now we have this new Helo X-Stream, and that was pretty much how we got there.
Right. Is it a geographically independent system? I guess you've got to be within the right satellite range, of course.
Correct, except for the poles.
Yeah.
It is a global service.
Right.
So anywhere in the world you can use the service other than 5 degrees towards the poles.
Right. Not too many guys flying up there, I guess.
Yeah, correct.
So that was you started in 2008, and when did you really start to make progress on it? When did you stop looking at this as a fielding concept and that you could bring it to market?
So I would say we had our biggest breakthrough probably around end 2016, beginning 2017, where we were running some extensive network tracing, and we figured out how the network was reacting was not necessarily the correct way. And by actually identifying that, we could actually create a or make changes on the network algorithms, how it does certain things. We could basically tell the network we are a rotoring aircraft when we register, and it can treat us in a completely different way.
Oh, right.
And it was the huge breakthrough. And then obviously since then we've gone through a rigorous testing campaign to verify it works on all the satellites, it works through all the different network SASs, etc., etc. So we only really started going to market in 2019.
So from where you are now, I mean, does it work better with one type of helicopter to another, or is it sort of agnostic of, because you talked about the number of blades potentially being a problem at the beginning. Is that solution finished now? And it doesn't matter whether it's a CH-47 or an Airbus 145.
Correct. And that's the great thing about this is in the past, we would say, okay, small helicopters with, less blades, narrow blades. We'd never had any problems with them. Something like a Bell 407, we have many of them flying. They didn't even need Helo X-Stream. They just work perfectly. As we start moving towards the medium-sized helicopters with wider blades, we started seeing packet loss and jitter, but it was still at a fairly acceptable level. You could work around it with some Kodiaks and some forward error correction. But the minute we started moving to large helicopter platforms, it was pretty much a no-go. It would work, but not good enough. The packet loss was too high, the jitter was too high. There was no real way to mitigate how it worked. So now, because we did all our testing on the helicopter platforms that we know are problematic, we are confident in saying that it should work well on all platforms.
Right.
And even one of our current customers is a Chinook, which has 2 rotor masts, and it's a really large helicopter, and it was successful.
You don't get
so
much
we're really confident that this service is now mitigating most of the things on the helicopter, most of the risk.
You don't get much bigger than a Chinook with the very wide blades, and of course double the problem with two blades.
Correct.
Intermeshing, if you like. Talking about, as we've gone on, or we'll go on to sort of a military context, we were talking earlier about Super Pumas, UH-60s. Have you done any trials with military? And can you talk a little bit about, or military or parapublic police, can you talk a little bit about the experience there?
Yeah, sure. We have, with one of our first customers for Helo X-Stream was German police flying a Super Puma, and following that we have some US government programs. That was where we obviously saw the Chinook and a UH-60 and then following that we also have the Austrian Special Forces also who have a UH-60 with the Helo X-Stream installed. So these are the military programs so far that we've been involved in.
Right.
Working on a few more.
Have they followed up yet with a sort of a buying signal? Are they going to buy, or is that still something that's in the development process?
No, we definitely have programs that are active and equipment being installed, and it may even move on to other platforms. The initial report back to us was they were extremely happy. Obviously, being ITAR controlled, we don't get all the information, but we definitely have a happy customer and we have active programs.
And the military always worry about adding weight to helicopters, but I don't think there's much weight in having this system over and above what they'd usually have in the helicopter, right?
Correct, yeah. The system, depending on the configuration, so we can go from a single channel to multi-channel, but your weight in the smallest single channel configuration, you're probably looking at around 7 kilograms. And in full 4-channel configuration, you're probably looking at about 11 kilograms. So it's really, for a helicopter, especially military-sized helicopters, it's insignificant.
That's good. How important is the sighting the antenna?
That is important. Obviously, the system uses geostationary satellites.
Right.
So we need to get navigational data from the aircraft, which we normally get via Airing 429. And then that will steer the antenna to the satellite at the highest elevation, which is an algorithm that's built into our aviator equipment. So, yes, it is important to steer to the correct satellite in order to get the service.
I'm just trying to think, the military helicopters often have a lot of other antennae on there as well, and various locations on and around the aircraft. So I was just trying to define whether, you needed a specific location or, it's obviously going to be on the top, the tail behind the engine somewhere, between the engine and the tail, right?
Yeah, in the past, before Helo X-Stream, we had very specific requirements on where to put the antenna. Now with Helo X-Stream, we actually have a lot more freedom to move it around pretty much anywhere. What we need to watch out for now at the moment is obviously exhaust gas temperatures. So the antenna can survive up to 85 degrees Celsius. So if you go too close to the exhaust, you can overheat the antenna. So that's one thing we need to look for. The other thing we need to look for is the best location for you not to point into yourself and cause blockage. So the one thing about a helicopter, because of the nature of a helicopter, your tail is actually lower than the body, and if you were flying towards, say, the satellite, and the satellite was at a say below 30 degrees elevation, you could actually start pointing into yourself or into the rotor mast. Right. In that case, it might be better to have the antenna above the cockpit if you're operating in that sort of area. In most operational scenarios, we find that larger helicopters prefer mounting the antenna on the tail.
Right.
Smaller helicopters prefer mounting the antenna above the cockpit because of the stabilizer and the downwash winds that antenna can cause. So it also comes down to the type of helicopter and what the installers are happy to do.
So the helicopters like UH-60, it would probably go somewhere near the above the pilots and on the cab.
So actually on the UH-60, we found the optimal, it's not really optimal location, but it's where the military actually prefers installing it because there's already a hard point there for mounting equipment is on the back, just between the two exhausts. So it's sort of midway, almost right to the top of the tail, sort of between the exhaust, and the exhaust on the UH-60 goes out on the sides. So it's quite a good location from a temperature point as well. And that's where both installations so far have done the installation, because it's got already provisioning for mounting equipment there without having to do any major structural changes to the aircraft.
Right. So once it's on and a customer's got it, but I mean, what's the requirement in terms of maintenance, repair, overhaul, longevity of it on the aircraft?
So our equipment is maintenance-free. So the Aviator SP system, it consists of line replaceable units, which is an STU, an HLD, and then the antenna. The only requirement that we state in our manuals is that every 600 hours we recommend inspecting the antenna for any possible damage. So on a standard maintenance check, just a visual inspection. But our equipment is maintenance-free.
Right. Oh, that's good. That's good to hear. Going back to something that you said earlier, you've now been able to show this to quite a number of people, I think. What's been the reaction from perhaps the user community when you've been able to demonstrate it to them?
The reaction has been twofold. One has been that they see it working, they're extremely happy, and they're ready to commit. But when dealing with customers that haven't actually seen it working, we still need to convince them that Satcom now actually works on helicopters. So one of the obstacles that we see right now is because in the past of Satcom not working, we have to prove that it is working, and then once they've seen it, then they're really happy and they move forward on it. So yes, that's the reality of it.
Yeah, I was going to say, what is the common misconceptions that you come across about people's views on receiving satellite communications from a helicopter? What do they believe? What are their misconceptions about what you're telling them?
I think the misconception is because they had a bad experience with Satcom on helicopter.
Right.
And they now...
So they maybe had experience 10 years ago.
Correct. So using the old systems, using whatever Satcom, they may have had a bad experience, and because of that, they need more persuasion. However, new programs, new helicopters, we find it's not so challenging because they're starting for the first time. They haven't tried it out before.
We're talking about bringing connectivity to every military platform or a lot of military platforms, which of course is now a rapidly growing requirement for all militaries operating across the world. So what exactly are the militaries looking for in terms of what this can deliver to them?
I would say that ISR beyond line of sight VHF radio extension are of the highest value to the military and probably one of the most sought after. I would definitely say that this product and service offering is more actually in line with military ops and paramilitary type services and not so much commercial office in the sky type applications.
Right.
Purely because it's a streaming service. It's really designed also for ISR video applications. Voice comms for beyond line of sight, getting sensor payload off an aircraft to a mission control center on the ground, things that Satcom brings to them and adds value to their operations, to their aircraft, and it really extends where they can operate, where they don't need to rely on having a line of sight to the aircraft. They can operate in all sorts of terrains, mountainous areas, and really get your sensor data to the command center anywhere in the world. They don't need to be, 100 or 200 kilometers in range. They can be anywhere around the world. And you can also send that data to multiple locations at the same time. So you could have mission control centers at 5 different locations, 10 different locations around the world watching the same stream at the same time. So these are things that the Satcom brings that you cannot do with the current setup. Yeah. And then we also have the added bonus of voice that could also be beneficial for operations.
It's almost making every platform sort of ISR agnostic, if you like, that if you've got a sensor turret and you've got connectivity through satellite, whether it's a utility helicopter or an attack or a reconnaissance, all of them are going to be able to feed into that general intelligence network.
Correct. And remember, it's also a bidirectional link. So it's not a one-way air to ground. It's also ground to air. So if they want to send back to the aircraft, instructions, whether it be via whichever way they do it, or if they wanted to control the sensor remotely from the ground, that's also possible. You could have just someone that's a pilot that's flying the helicopter, and you could have no passengers, and you could actually have someone sitting on a ground mission center controlling the camera or whatever sensor you're using, radar, etc., and this is all happening via the Satcom. So it is a bidirectional link, and it can really add value to operations.
Right. Troops on the ground and may just be able to utilize a passing helicopter rather than call up a specialist aircraft that they'd usually do today.
Correct. It might even be that they send a video or picture to troops on the ground to give them situational awareness of somewhere they're going in blind, but they've got a high-flying helicopter with long-range FLIR camera, and they could know where to move in and those are all the type of applications that this will bring to the military.
Looking at it from a purely data point of view, you look now, or I've been looking recently at the expansion of unmanned rotorcraft, particularly in the maritime environment. So if you're looking just to transmit data virtually real time, I guess it would be applicable to be mounted on the selection of those unmanned rotorcraft that are coming to the fore?
Correct. So on larger type platforms that can take the payload weights of our current Aviator SP system, they definitely can install our system. We also have dedicated UAV products, Aviator 200, which is dedicated for smaller UAVs that can't handle high weight payloads. So in those applications, that's for payloads of 1.45 kilograms or lower.
That's useful.
Which also supports helicopter waveform as well.
Right. In terms of the technology that's now coming in terms of military and data transmission, what is the weakest link in the chain, I guess?
Weakest link probably is that L-band is not the highest bandwidth. However, saying that, it also is very much more resilient to weather conditions and blockages, etc., to other technologies like Ku-Ka band, which are virtually impossible to get working on helicopters. So the downside is a lot of the challenge of getting, say, maybe video over a link at 25 frames, full HD, is challenging. So what we did to mitigate that was we actually, in our Aviator SP product, we have the ability to bond up to 4 channels, and that can give us much better. Then we can start doing full HD 25 frames type of ISO applications. So we have a solution to the problem, but I would say that if you're comparing it to sort of a ground-based LTE network, you're not going to see the 3-4 megabit speeds that we kind of get used to in the modern world right now. But we have to also understand that to get a link on a helicopter that's reliable and working. It also is very much dependent on the frequency that we use, and that frequency only carries so much bandwidth capability.
Well, I know when the military are engaging in ops, particularly when you've got troops inside a helicopter, the one thing they've been screaming out for years is good situational awareness. And that's up-to-date information coming through to the helicopter, which, in early days and in Afghanistan wasn't really there. So this is just giving a good portion of that to what the military require for those kind of operations.
The military can really benefit from having connectivity, especially for voice. You can extend your VHF radio capabilities, push-to-talk. We have devices, so you can actually use the Satcom in a beyond line of sight type operation and then still talk to your troops on the ground via satellite relay to VHF. So the applications are endless. Having voice to phone operational centers, which in the past you were always restricted by how far your radio would operate. Yeah. And then obviously getting data off the aircraft can be used for tracking the aircraft in real time. We have all those features built in as well.
Yeah. Force tracker, that's something that's very important in any battlefield scenario. Tracking your own forces. Knowing where everything is at any time. It's up and running. It's now available. Where do you go from here? How do you make it better? Or what's the next project, should I say?
Going from here is getting it out into the market to let them know that there is now a tested working solution. We've got a really great white paper that we've written that summarizes all the results from our test campaign and shows how drastic the improvement is. It really is a huge night and day difference between having Helo X-Stream and not having Helo X-Stream in performance, throughput, packet loss, all that type of stuff that used to cause problems has been almost totally mitigated with the service. So I think going forward is just trying to educate and convince people that it is now a working service.
If people want to find out more about the white paper and the technology, where should they look?
We have a dedicated microsite. It's actually outoftheshadows.aero, where you can find all sorts of things like videos, white paper, literature, etc. It's definitely one of the best places to get all the information summarized in one place.
So that's the place for them to go. Once more, outoftheshadows.aero. Okay, Shaun Schaper, thank you very much for being our guest today. Good luck with the rest of the development and in bringing the knowledge to the helicopter community. And thanks for participating in the Armada International podcast.
Thanks so much. I really appreciate your time as well. And we'll speak soon.